Welcome back to Structural Basic USA. So far in this series, we've learned how to convert PSF into PLF. We've learned how tributary width determines the load received by a beam. And we've learned about dead load, live load, roof live load, and snow load. Today, we're finally going to put everything together. We're going to calculate the actual load acting on a beam. Imagine we're designing a simple residential roof beam. The roof dead load is 20 pounds per square foot. The roof live load is 20 pounds per square foot. And the tributary width is 8 feet. Now comes the question, what load does the beam actually carry? The answer is simple. The beam receives every load that travels through it. Dead load travels to the beam. Roof live load travels to the beam. And both loads contribute to the total beam load. Let's start with dead load. The roof dead load is 20 pounds per square foot. The tributary width is 8 feet. To convert the area load into a beam load, we multiply by the tributary width. 20 pounds per square foot times 8 feet equals 160 pounds per linear foot of dead load. Now let's do the same thing for roof live load. The roof live load is also 20 pounds per square foot. The tributary width is still 8 feet. 20 pounds per square foot times 8 feet equals 160 pounds per linear foot. So the beam also receives 160 pounds per linear foot of roof live load. Now we can combine them. Dead load contributes 160 PLF. Roof live load contributes another 160 PLF. Together, the total service load becomes 320 PLF. For today's example, we're using a simple service load case to understand the basic concept. In real structural design, engineers use load combinations defined by ASCE 7. Those combinations determine how different loads interact with each other. But don't worry about that just yet. For now, our goal is simply to understand where beam loads come from. We'll explore load combinations later in the series. Now let's pause for a second. Notice something important. We did not convert the total load. Instead, we converted each load separately. Dead load became 160 PLF. Roof live load became 160 PLF. Then we combined them. This is exactly how engineers think about loads. Now let's change one thing. Suppose the tributary width doubles. Instead of 8 feet, it becomes 16 feet. The roof dead load is still 20 pounds per square foot. The roof live load is still 20 pounds per square foot. But now, dead load becomes 320 PLF. And roof live load also becomes 320 PLF. Together, the beam now carries 640 PLF. Notice what happened. The load values didn't change. The material didn't change. The code didn't change. The only thing that changed was the tributary width. And suddenly, the beam load doubled. That's why tributary width is one of the most important concepts in structural design. One common mistake beginners make is using the PSF value directly for beam calculations. Another common mistake is using the entire roof width instead of the tributary width. Both mistakes can lead to the wrong beam design. As engineers, we don't just copy numbers from a plan. We need to understand where those numbers come from and how the load travels through the structure. Roof sheathing transfers load to rafters. Rafters transfer load to the beam. The beam transfers load to posts. And the posts transfer load to the foundation. That is the load path. So here's the workflow. Identify the loads. Determine the tributary width. Convert each load from PSF to PLF. Then combine them to determine the beam load. Load, tributary width, beam load. That is the foundation of beam design. Now we know the load acting on the beam, But what does that load actually do to the beam? It creates bending, it creates shear, and it creates deflection. In the next video, we'll start with bending moment, and that's where structural analysis really begins. See you in the next video.